Cool. So we got recording going. Good. Thank you everyone for joining today. We're going to go over, we have 3 topics on the agenda. So first up, Gilles could talk about some work he's been doing for VM inventory. Derek's going to talk to us about some improvements he's done for remote cache clients. And Eric's going to talk a little bit about what he created for basically a knowledge share website that everyone can contribute engineering documents to. So first off, Gilles, are you ready to take it away? Not able to hear you, Gilles. Not yet.
Yeah, can you hear me now?
Yep.
Okay, cool. Thanks. Thanks, John. So, yeah, today we're going to talk about the OPAL, or the on-premise analytical layer. So I'm going to share one of my tabs. There we go. Can you guys see that okay?
Looks good.
All right. So in the previous session, we talked about the OPAL backend. So it was more like the work that was done on alongside the MTV controller inventory, or inventory controller. So now today we're going to see the prototype. It's more like on the UI side of things, leveraging what we've done before on the back end. So we're going to see how we can take benefit of that work with the back end around the MTV inventory data, and how that could help us solve stories raised by OPAL use cases. So what's happening here? Here we go. So having providers data structure expressed as a graph gives us a lot of flexibility. It allows us to have a better user experience and a more user-friendly view, views such as vCenter, similar type of view, and also the VM-centric views. And on top of that, we could add fast and advanced search capabilities. And from there, we'll be able to store, export, and feed migration plans from selected VM sets. The OPAL modules are easily usable or integratable. So the backend can be integrated. Sorry, it's just going a bit fast here. I'm going to slow down. Can be integrated as part of the forklift. I thought I paused it. Sorry. Here we go. So yeah, it can be integrated as part of the forklift inventory controller. So we've got the module on the back end, and there's the module on the front end. So basically, it's just a GraphQL wrapper around the inventory. So it's leveraging the resources we already have there, and then passing that to the client through a GraphQL client. So there we go. So we're going to see like 3 main type of views. So the idea, we'll see that in action in the following demo. But the idea is to give VMware vCenter administrators an equivalent views, sort of like giving them a feeling of being at home by using the same data tree type of organization. And underneath, we're using the same data tree as vSphere user interface. In the same idea, we will also see how we can traverse data across 3 views. So again, it's very similar to what administrator sees in vSphere. So when you click on an item, then it takes you to that tree representation of that object's view. And the other main view we're going to see is the VM searching and filtering, which is the sort of putting all together the search on VM. So basically, while tree views help us finding our way around the inventory, we need to narrow down on set of VMs. And for that, we flatten tree views. And this is an example of the host and cluster flat tree that allows us to search an entire set of VMs and applying filtering on top of that. So on various like criteria, preset criteria, and also searching on patterns, so the user can narrow down the set of VMs he wants to apply a migration for. Sorry about the delay here. Here we go. From a technical point of view, we have the graph approach not only gives us flexibility, but also proves efficient in terms of data fetching. So where each set of data is retrieved once for each tree. So it's basically reducing the number of travel between the UI and the backend. So in one request, we get an entire tree set, and then the UI works from there. And also, it's important to note that the entire OPAL source code, backend and frontend, without the frameworks, is about 1,500 lines of code. So it's not like a lot, I think. But so to see that in action, I'm going to show you the prototype for the OPAL we have so far. So the first vSphere provider view is the host and cluster. It breaks down VMs by data center, clusters, and hosts, like similarly as what we have in the forklift UI. And by selecting any element of the tree, we can obtain the detail about that object. So basically, if you click on the node, you get information about that node, whether it's a data center, a cluster, a host, or at the leaf level, it's the VM itself. Similarly, we have the VM and templates view that shows VMs broken down by folders. So with the same approach, you have the different node element, and then the leaf. At the leaf level, you have the virtual machine. So there is not like an extensive set of data here, just for the prototype sake. And we have similarly the storage and networking tree views. So again, this is like similar to what we have in vSphere. And so same thing, when you click on the storage, you obtain the data about that storage element or network component. And that's it. So that's a bit out of scope, but I also did the same approach for showing, like, breaking down the OpenShift tree views. So we have the namespace and virtual machines here as an example, but that was not initially needed. So next we have the traversal feature. So I'm just going to go back a little bit here. So you see this is pre-recorded. So when you click on an element as a VM, you have various information here. And then if we click on or we select a sub element like the data store here, it takes us across to the storage tree to that element. So that's that's the traversal feature. And same thing for the network. Now, to filter VMs, we have another view, which is in a separate tab here for the prototype. So we use a flattened table of the host and cluster tree. And from here, the user can like filter and narrow down his VM sets. So here we search on the VM name, or we can search on any criteria that we like to provide the user with. So like the constant here, and we have like, I added a few other examples, like the power state of the VM. So VM could be on and off. So the user can select that here, and in this example, there's only one VM that matches all these criteria. So that's about it for the demo. As I said, from the technical side of things, we have a very efficient fetch process here, where everything we've seen here has been covered with this 6 requests between the UI and the backend. And that's I think that's about it. For the demo, just checking if I didn't forget anything. And yeah, so well, what's next for OPAL is a bit early, I suppose. Depends the feedback we're going to get from you guys, and if what we can do from there, basically. I mean, there's other features or the use cases that have not been covered yet, like the reporting and exporting feature, and how we can integrate that with the forklift UI. The backend microarchitecture is just thought about how we could integrate better with the existing forklift API. So that's all I've got today. And maybe if we have time for question now.
Any questions for Gilles?
Yeah, Gilles, this is Vince. Is the idea that this would replace having to add VMware as a provider? I'm missing the big picture on what this is for.
Oh yeah, so the idea is to be able to exploit the VMware inventory better. I mean, and provide the user a better experience with that. So I think one of the key points was providing views of the data that are similar to what the VMware administrator are familiar with. So it's the same sort of basically same layout or similar layout of the data structure that they found in vSphere UI. But
okay,
yeah,
so without having to go into vSphere.
Well, yeah, basically, I suppose if yeah, because we hook to it. So I mean, if they can find the same information, then they don't have to do the swivel chair kind of experience where they're going to go from one screen to another. If everything is there or everything they need for the migration is there, then they won't have to go across the UIs.
Vince, this is Brett. So maybe it's a better way to look at this is we've added the VMware Provider. We're collecting additional attributes from those virtual machines, storing those in the inventory for MTV or forklift per se here. And then this tooling allows you to see more detail of that VM to understand what that may look like on a migration. We could potentially tie that into say some of the open policy agent rules that we have in place for doing that VM migration, but it's more about getting more of that introspective data to understand that over time. It could be, hey, we see some application relationships here. We see some other relationships that might cause some of those migration failures to happen. So think of it kind of like a next level, next step of what we could do with OPA.
Okay, thanks.
Yeah, the initial idea was when you are in the forklift UI today, you basically have to know which VMs you want to migrate. When there you may have the 10,000 VMs in that giant table, and you're using criteria to find the ones that are alike, either to migrate them together or to fix the specific concerns we have on the VM. So basically, you could find all the VMs with well, I don't know, PCI pass-through, let's say, and you would want to potentially change the configuration before the migration because PCI pass-through is not supported on the destination. So you can find big masses of problems or identify VMs that are likely to be migrated together.
Okay.
Yeah, and then I was going to add if we look at the current forklift UI, it's basically they will be extending the VM selection part of the migration plan creation. So when you filter, it breaks down in two parts. There's the filtering part where the users select the VM location, the data center, and so we could have here those different views on the vSphere, similar kind of views, but not just only the host and cluster. It could also be the VM template view where everything is broken down by folders. So if people want to search for a VM that way, well, we could offer that approach. And then the second part is the select VMs, so offer more granularity on the VM selection with adding more filtering capabilities. So I think that would be like the drop-in, or the initial, so to speak, drop-in place for those views. If that makes sense.
Okay. Thanks.
So Gilles, Fabian, so it will actually replace the existing UIs that we have for inventory, choosing the VMs and validating in the inventory?
Well,
Yeah, sorry, go ahead.
no, I was going to say it's a prototype just to see how we can manipulate the data differently. The one we have in Forklift UI is one way. It's very directed toward the plan. You already know what the VMs are, which VM you want to migrate. So you find them in the folder or on the host. Basically, you already have your list of VMs. With this one, it's a different approach. You're trying to find common criteria between VMs to group them and create a plan from that. So it's a different approach. It's just an exploratory work for now. So it doesn't mean it's going to replace the Forklift UI, but we're trying to look at alternatives on how we manage that big amount of data we have.
So it could be like what we were talking about way back when we had migration analytics, where you actually create the migration plan outside of the MTV UI.
Yeah.
And just import the list of VMs.
Yeah, and potentially that UI could also be cross-provider. The interest of that is you could, instead of when you're creating when you're creating a plan, you already decided which provider, source and destination provider you want. Here, if you've got all the data, you could actually match some VMs from multiple VMware providers at the same time to one specific OpenShift with some rules where you say, okay, this one is a better fit, depending on what's present on the VMs and what you know about the configuration. It's more about the analytics and the initial user experience we are providing now.
Gotcha.
Technical question from Sean. Why GraphQL and not using the inventory service directly? One of the reasons is because we can. And I think one of the reasons is GraphQL provides you a native way to traverse the graph of relationships when the inventory, either you're going to download the whole inventory at once and resolve all the relationships directly in the UI in memory, or you're going to do a lot of requests to get every possible relationships you need to build that kind of experience. So it was a way for us to try something else. Doesn't mean it is the right way to do it. It's not GraphQL is better than REST, but it was also a way to explore something different. And Gilles, you might be more opinionated even more than me on that.
Yeah, well, yeah. So the way I approached it, I was trying. I mean, I think it relates to Vince's question. It's like about replacement. The idea was not to replace anything, but more like an add-on, like keep composing and enhance. But from the GraphQL API point of view, this is entirely using the existing inventory. So currently the inventory provides 2 trees views, but I would say it's not like it's kind of much easier to handle graphs with GraphQL because it's designed for that. I mean, they're complementary. I mean, I'm not saying GraphQL is replacing REST, but I suppose it's like for complex APIs, GraphQL provide very very powerful tools. Yeah. So in terms of complexity, how much complexity is it adding? I mean, not much. I mean, the prototype is currently built on top of a pattern line. I mean, I did that, of course, to have a similar view, but also because I kept in mind that would be like an add-on. So it's like we could just reuse the pieces and drop that into Forklift UI, or it could be even used for I don't know, you can see any case for now for MTC, but could be as well because we're using exactly the same platform underneath. So using React query and using the inventory API, which is basically wrapping it from the GraphQL backend point of view again. So yeah, there's just a GraphQL client and GraphQL server that just is built on top of the existing Express service we already have. So basically, once the graph is there's an initial graph that is built, so the rows that fetches all the different nodes, it's very easy to add more feature on top of it. And the backend is about 700 lines of code. So I don't know if that answered much of the complexity question, but maybe part of it.
The next question is, do we have to build with that? Absolutely not. I mean, it's I said earlier, it's exploratory work. So far, it's not even on the roadmap or anything. If we think it provides value to the user, we might be doing that. Do we have to handle releasing the GraphQL stuff agent? I think that's not the only product within Red Hat with GraphQL, so I'm pretty sure other people are dealing with CVE, and we would follow their previous experience on that. But that's a fair point, that anytime we introduce a new technology, we need to be really wary about the how to release and manage the security on that. That's a great point.
Yeah, well, we're using NPM, JavaScript NPM modules. So again, there's like a couple of modules, respectively for the backend and the UI.
Any other questions on this topic? Okay. Thank you, Jill. Next up is Derek, and Derek is going to talk to us about work he's been doing on the remote cache client. Derek, all yours.
Thanks. Can you guys hear me all right?
Yep, hear you well.
Sweet. Cool. So yeah, in Crane and MTC 150, we were doing some work on performance enhancement. And to inform where we focused that effort on performance enhancement, we've been applying some investments that we've made into Jager Tracing and Prometheus Metrics in our tool. So a little bit about Crane and MTC for the uninitiated. Migration Toolkit for Containers is a piece of software that helps you to migrate your apps from one OpenShift cluster to another. And that includes both the Kubernetes resources and the persistent volume state. MTC is the downstream and Crane is the upstream project. This tool is based off of Valero for all of the Kubernetes resource backups and restores. And we have a rsync-based PV state transfer module. We also have a really nice migration UI, which I'll show in the next slide. And this is installed as an operator on OpenShift 4. So this is what our UI looks like for Crane MTC. We have a way to specify the clusters that you want to migrate apps between, the namespaces, the PVs, copy options, etc. So it's kind of an all-in-one tool to help you migrate your workloads from one cluster to another. What is Jaeger tracing? So this is one of the things that aided us in figuring out where these performance gain opportunities existed. Jaeger tracing describes itself as open source end-to-end distributed tracing. And this is especially useful if you have some sort of software that has multiple services that are all interacting to achieve some shared goal. In our case, we have 10 subcontrollers inside of our migration controller that are all doing different tasks, pushing towards that migrated app state. And we also have Valero in the mix that's doing, some other pieces. And sometimes we want to be able to see how do all of these subcomponents, these services, interact as they're pushing towards that goal, because it makes it a lot easier to understand where you have opportunities to improve performance. A little bit more about Jaeger. It's available as an operator on OpenShift. So it's kind of a two-piece system. You export traces from your app, and then they get collected into a Jaeger collector. So the operator that you can install into OpenShift serves as a collector. And it also has a web UI, so you can view traces that are exported. Pretty seamless system to use. What is in a Jaeger trace? So here's an example trace. This is a reconcile of our migration plan controller. And here you can see this is actually just a single service. You can see that by the fact that everything is just color coded in the same color of sort of teal over here. But this is showing you inside of a single reconcile of migration plan. These are all the sort of sub functions that run and the associated timing. You can also understand what's able to run in parallel and what is running in sort of a serial fashion. So this is a super easy way to visualize the performance of your system. And just to give this a little more of a concrete, to give you a little bit more of a concrete idea of what's happening here, each of these they're called spans. So the top level item is a trace, and everything underneath it is a span, and you can have sub-spans under spans. Each one of these spans is set up inside of our code. So we have a tracer that's running. It's just a package that you import. Everything in Jaeger is based off of the open tracing standard. So Jaeger is not the only option for tracing, but that's what we're using. And we pass around our spans inside of context, which is a concept in Go. And then anytime we're in a function, if tracing is enabled, we're able to start up a subspan and get really granular information on what's happening. So just to jump back, you can see now that you kind of know what these refer to, you can see like one of these functions was taking 189 milliseconds. Almost everything inside of our validation routine runs in microseconds. And there's two main things that we might want to look at for performance optimization here. Just a little bit more on Jaeger. So just to try to educate folks, if you are using Jaeger and you want to view your traces, you can see sort of this nice trace view. You can filter by service, by operation type. You can add tags to individual spans and traces, and you can specify duration of traces, etc. If you want to find the most high latency traces that were recorded by the system so that you can understand the worst case scenario, you can do that type of thing. And this shows the aspect where you can view multiple systems, multiple services interacting together. So here we have a migration. So in MTC, we collect all of the tracing information sort of unified under a single migration, because the migration is the sort of unit of work that's being pushed towards. And there's all these 10 or 11 services that are all working together to push towards that. So under a single migration, you can see all of these individual services that are color-coded here that are working towards that fully migrated state. And you can see their interaction here on the right, where sometimes they're running in parallel to each other. Sometimes they're running in serial, as I mentioned. what is Prometheus? So Prometheus is another thing that we used in our sort of quest for performance here. We added Prometheus Metrics a few releases back that give us insights into how long our client, our Kubernetes client, takes to do certain transactions with the API server in Kubernetes. And this is essentially a time series database that provides powerful querying, visualization, etc. So if you have an app that you want to push metrics out of into a database so that you can understand over time how your application is performing, you can write an exporter for your app with the Prometheus instrumentation libraries. And that's easy to push into the on-cluster Prometheus instance. So OpenShift has first-class support for Prometheus. The API server itself and other components of the control plane are instrumented. So you can see just inside of the OCP dashboard, we actually have API performance as a thing you can see right here. And it's also possible to push your application's metrics into this on-cluster Prometheus so that you can either have metrics and alerting or even send back information as part of telemeter payloads. So here we're just seeing the 99th percentile worst case API request duration. And here's another view. This is Grafana. This is something that's sort of tightly wound in with Prometheus in a lot of cases. It's a even more powerful visualization tool for those Prometheus metrics, time series data. And we use that sometimes to just help us understand better what's going on. So in the case of Migration Toolkit for Containers in 1.5.0, in our most recent release, what did we learn from it? Just looking at I guess our overall goal was to figure out what's the biggest impact we can make on performance in the amount of time we have for this release. And looking at all the metrics, it was obvious that there were a lot of different areas that could be improved. But from just looking at this, I noticed at one point that when I had a cache turned on for the Kubernetes client, there's a lot of operations that shrunk down from like 1.5 seconds or 989 milliseconds down to microseconds. So you're talking like 1,000 times improvement in speed for those types of operations. So just looking at a few comparisons between traces with a feature flag turned on versus off allowed for a really obvious conclusion that it makes sense for us to give this option to our users to enable them to experience faster app migrations. In this case, what we're seeing here is the persistent volume discovery workflow. Anytime you're creating a migration plan, you have to discover the volumes, the data that is inside of the namespaces that you'll be migrating. And since this is a lot of read operations against the API server to go crawl through all that information, it helps a lot if we've got a local cache of that. So the big change that we've made in MTC 1.5.0 based off these insights is reintroduction of the cache client to give users the ability to have that performance unlocked. This is just a little bit more of a zoomed in view, seeing how there's several parts of this migration plan validation routine that take on the order of near a second or half a second. And then when we run that with the cache client again, those shrink down to the range of microseconds. So just because of the stark difference there, you can tell that something is very much different. And we can assume that in these other parts of the validation where there's still a little bit of time taken, there's some other operation there that is not an API server read. It's probably either write or some other operation that takes more time. In terms of the Prometheus metrics, what did we learn? So we have client metrics, as I mentioned. So we're able to see for our built-in Kubernetes client, how many list calls did it do? How many get calls? How many creates, updates, deletes? And we're also able to see the API latency, the end-to-end round trip time that it takes for those requests to come back. So using some queries that I came up with against these are Prometheus queries. So it's PromQL, the query language for Prometheus. You're able to sort of build up these queries that tell you this is the total number of reads that happen over the course of an app migration in blue. And in green, we have the total number of writes against the API server. So what this revealed is that our controller is super read heavy. It's doing not quite 20 times, but more than 10 times as many reads as writes. So this is a case where the evidence is, again, stacking on to show us that we should consider trying to get a cache enabled in this system. So how did we do the performance tuning based on these metrics and tracing insights? We turned cache clients back on. So the big benefit of that, of course, is increasing migration speed. And I've got a little demo here I can show you the big difference that we saw when we were able to turn on those cache clients again. And in this case, I was connecting my migration controller from my laptop to US East. I measured the latency before running the test and found it to be 22 milliseconds. And I've got a pretty powerful connection here, so I don't think there's any bottleneck, mainly just the latency at play in terms of slowdowns on the network side. So let's jump over to that.
Hey, Derek, just a simple question. I just want to make sure I understand the context. So the cache is between the controller, in this case, which is the client, and the OpenShift API. So the controller can cache some of those transactions going on. Is that the right understanding?
That's exactly right. So
Okay.
basically, yeah, the API server, instead of us asking for the information that we want from it, it actually sends us updates anytime anything updates on its end. So we always have the most up-to-date information before we even ask for it, and we cache it in memory in the controller.
Cool.
Yep. Uh-oh.
So the more latency you have, the bigger of an impact the cache will have, I guess.
That's exactly right. You actually brought us a case, I think during 1.4.0 release or something, where we saw a lot higher latency than I had expected was possible. I think we saw you had a migration that was taking around 6 minutes. This type of improvement will really handle that situation well, because that's a really latency heavy environment. In a lot of cases, it's not going to be as pronounced, but it's always still going to be an improvement from what we've seen so far when you do introduce cache. So basically, this is a side-by-side comparison of with and without the cache. On the left-hand side, you can see without the cache, it's still in the prepare phase, while the with cache migration has already flown through the first 5 steps and is doing the rsync. Basically, there are quite a few operations inside of the migration that are read heavy, and anything that just has to read from the API server can do that read in microseconds. Anything that has to do a write, it still has to actually contact the API server directly, so it's going to be whatever the network latency and all the other latencies that are involved to make that write operation. But since we do so many reads in the migration, this is super effective from what we found. It took 82 seconds for the migration with the cache to finish, and we'll see it's going to keep running without a cache for a little while here, but we'll see that it took a little over twice as long to finish without a cache. And when you have more network latency, let's say you were doing a migration from across the United States, this is going to be even more pronounced. So 198 seconds versus 82 seconds, pretty significant improvement there. Let's see.
And outside of having the cache on or off, is there other parameters? Can you specify like after how many times the cache expires, as an example, and things like that? Like, because if the apps have, I don't know, like if you have something in the cache that is not real anymore, is there a risk that we're migrating something that is not the latest? Like,
so the cache stays up to date within a few milliseconds of of ground truth, because like I said, the API server is sending us any new information that it has as soon as it gets it. It's just a matter of that network latency with us. Maybe it would take a few milliseconds for us to get the most up-to-date copy of a resource when it changes on the API server. So it actually does, you do incur a little bit of load on the API server because you are having it send you everything, but it is at least on a persistent connection. So you're not having to do quite so much overhead with individual requests. I think it's a bit more efficient to have it send you everything. However, there is a little bit of a drawback with this in that with the controller runtime cache, which I'll get into this a little later, you don't have complete control, at least not in the version that we're on, over what gets sent back to you. So in this case, when you turn the cache on, you're basically caching the entire cluster almost. And etcd, which is where all the stuff in Kubernetes gets stored, has a max recommended size of like 8 gigabytes. So theoretically, we can't really grow our memory much bigger than that, assuming we're storing it in somewhat of a similar fashion. But that's still pretty big. That's a lot of memory consumption. So this is why it's an optional feature flag right now, because we haven't quite had time to fully explore what the maximum memory that could be taken up by the cache is. We have done tests, but we haven't been able to get it to expand in memory as much as we've seen in some user environments. So there's still some sort of discrepancy there that we're trying to figure out. So like I said, when you do have the cache, you're not sending your reads straight to the API server. Instead, the API server is sending all of the information directly to you because you have that persistent connection with it. And one of the drawbacks of cache clients, of course, is the increased memory consumption, as I just discussed. So right now, this is behind a feature flag. I think there are probably a lot of users of the tool who are running this tool, though, on their empty OpenShift 4 cluster. And they should be able to afford extra memory consumption because they've got a cluster that's vacant. It will only consume extra memory on the cluster where you're running the controller. The other issue you do have to deal with, which Marco brought up, is cache staleness. So this is something that we dealt with early on because the default behavior is actually to have a cache turned on. And we found that we weren't able to reliably keep the cache turned on initially because the cache, you could do a write to the API server, and then milliseconds later or less, you could ask the API server, hey, can you give me that resource that I just wrote? And the API server, or more accurately, the cache wouldn't yet know about that resource. So it would say, sorry, I don't have that. I don't know what you're talking about. So that threw off a lot of our logic. And since we have had the cache turned off for a long time, the code base in some ways is not adapted for this. So there's a workaround that we implemented in MTC 1.5 to address this. This stale cache behavior is sort of a known characteristic of controller runtime. I'm not sure that we fully understood this at the beginning of development of the migration controller, but they suggest several approaches for dealing with this. In our case, the problem that we had was a little different than anything that's described in these few paragraphs they provide, but it probably would be possible to write a controller that would not need the workaround we have. However, this workaround allows us to not have to think quite as hard and not have to do so much refactoring in the code base. One of the big problems with trying to resolve these problems is that with the huge amount of surface area we have for logic in the controller, there's a lot of problems that can go unnoticed for a while if you have a lagging cache that will only present themselves in a user environment after you've released the software. So to get around this, we've basically done something where anytime we write to the API server, we pull the cache until it populates. So we're forcing the cache to be consistent in some way, at least for the things that we write to the cache, because those are typically the types of things that we expect to be there and will ask for soon after, and will probably error out and fail the migration if we don't find them there. So because of this, we're able to write to the API server, pull the cache until population, and then return the result to the caller. And because of the mixture of reads and writes that we do in the migration controller, we actually see very good performance with this scheme. So you might expect that there would be a little bit of slowdown since you do have to wait for the cache to populate. But from empirical observation, it appears that this normally only takes a few milliseconds for the cache population to occur. So in MTC 1.5.0, you can turn this on and off with the feature flag. It's turned off by default. We need to get more mileage on it. One other thing I do want to mention, even if you don't turn on this cache feature flag, we've also made other performance enhancements in MTC 1.5.0, specifically around saving the clients that we create so that we're not regenerating them all the time. That on its own makes a significant impact to migration speed. So that doesn't address the problem with network latency, But we also discovered that there was around 500 milliseconds of time that we were wasting per client creation in our code, which is happening all over the place from this tracing. So there's performance benefits regardless of whether you're able to turn this feature flag on. This is just kind of like the cherry on top. So I think that's all I have. I did want to quickly show, in case anyone's curious about Jaeger, we do have inside of our MIG controller hacking.md a section on Jaeger that I wrote up. It basically describes what we're doing with Jaeger, how to run the Jaeger collector locally, how to enable Jager tracing in the controller, and how to use the basic features. One of the things that I didn't really get to show is you can look at statistics for traces in Jaeger. So if you want to see the performance of a particular span or a particular trace over time, you can see like the average runtime, minimum, maximum, and also how many times it happened over the course of a trace. So I think that's all I have. Any questions?
Awesome work, Derek. That's really cool.
Thank you.
And good presentation. I kept asking questions before you were at that slide, so I apologize.
No worries.
No
worries.
Any questions for Derek?
Yes. So I asked if it's used in MTV. So Scott said that it might be already used there as a cache.
It's
Yeah,
not that
so
much I catch, but could we use Jager so we know where the problems are in MTV? Because there might be other problem than caching.
So for MTV, we are using Prometheus. I asked Mordechai to join. We are using Prometheus and Grafana. Mordechai, what else we are using for monitoring the performance there?
We're not using anything that's going to give you functionality like Jaeger internal tracing right now. I think it's something we definitely look to add, especially as we start getting past these more straightforward issues and start seeing issues that are related to complex interactions, which Jaeger shines at. So today we're just using basic looks at Prometheus and going through overall usage values and looking how we're scaling with actions. I think as MTV matures in terms of coverage, then the bugs look a bit more complex, and then tracing is an absolute must.
Yeah, but already we were able to find the memory consumptions and CPU. We just looking on this, and bugs were fixed like just recently on these areas.
How much effort was it to put this on MTC? Like, how much time do you think?
With Jaeger?
Yeah.
So
was most of the challenge to learn it first, I guess.
Yeah. I guess what was unclear was how to apply it to this paradigm of having, like, basically how to apply it to a controller runtime controller. There's not a lot of documentation out there that describes like how to architect your Jaeger implementation. So the way I did it is Jaeger is typically, I think, used where you treat each service, you have like a microservices architecture like that, and each service may be contributing something to the overall end goal of the system. In our case, we do have sort of these sub-controllers, but they're technically all under the same process. It's just like all of these controllers are running under one manager. So I'm treating those all as separate services because that's sort of a useful way to view it in the system. So it took a while to get to that point just to figure out how this made sense for us. The actual instrumentation, if you know what you want, it doesn't take long. It is a lot of just like copying, pasting to start the spans in the right places and things like that. I think I'm still learning the most efficient way to set some of this stuff up, but it was pretty easy overall. It probably took a week of concentrated effort if I summed it up over time. It didn't happen over 1 week, but I think maybe that would be how long I spent on it in total.
Cool.
Any other questions? Great. Thank you, Derek. That was really awesome.
Hmm.
And the last topic, I think we're going to have to defer to the next meeting. Eric was going to share some of the work he did for the Keybase site, but Eric wasn't able to join. He had something come up. So I think that wraps up right now, unless anybody has any other topics they want to discuss. Well, thanks everyone. Have a good day.
So guys.
Thanks. See ya.